While there's a lot of talk about artificial intelligence these days, I hear very little actual intelligence. The field of artificial intelligence has actually been around way longer than computers, with one example being intricate devices called automatons that emulated human motion and/or behavior. There are also mechanical board games like The Amazing Dr. Nim, which could emulate a smart player using no electricity, drive shaft, or springs. When most people refer to artificial intelligence today, they are actually referring to a small subset of modern AI, which can be best described as brute force math. You may be wondering what I mean, so let me explain. In the past, when a computer programmer wanted to achieve a particular outcome with a computer, they had to actually understand the math equation that they needed to code up for the computer to compute the result they were looking for given a particular set of input data. For example, if you wanted to produce an image where the lighting interacted with an object that appears to be made of glass, you had to actually come up with the equations to simulate light coming from a particular source, bouncing around your scene, and hitting your virtual camera to generate the desired image. Fortunately for the computer programmers, there were often equations being developed in other scientific disciplines to approximate various phenomena as seen in the natural world. However, those equations were generally too costly to compute in full in a computer, and the programmers would need to figure out ways to simplify or approximate those equations to produce a good enough result. To do this required a good understanding both of the limitations of the computer and math. Today, with several decades of hardware advancement, most people have more computing power in their pocket than they know what to do with. This surplus of compute power enables modern programmers the ability to let computers brute force a solution to various math problems instead of coming up with the equation themselves. If they know what kind of output they want given certain inputs, they can let the computer randomly try billions of different equations until they find one that matches their criteria. Want a program that takes text and outputs an image? Simply get a large database of images and descriptions and try a bunch of math equations until you find one that gets you the good enough solution you are looking for. Much of the surprise people have over the capabilities of modern AI systems can be boiled down to a lack of understanding in regard to what all can be accomplished with math. All computer-generated images and movies are made using math. Many synthesizers and digital instruments which have been used in the music industry are made using math. Auto-tuning of singers is done using math. Voice recognition services are also made using math. I think you get my point. While your math teacher likely failed to help you see why math had any relevance in your life, everything you do with a computer can be boiled down to math. The difference now is that while in the past the programmers intimately knew and understood the math that their programs were using, the programs of today are using math that was literally brute forced into existence and appears totally opaque to the programmer. When programmers use modern AI techniques, or brute force math, to run their programs, they start out with some major assumptions. First, they assume that the problem they're trying to solve can be adequately solved purely with math. Second, they assume that the set of inputs they have selected are all the right inputs needed to produce the outcome they desire. Third, they assume they have, or can come up with, a dataset that fully encompasses the problem space they are trying to solve, and that they will be able to fully solve the problem including all edge cases. Math is great and can be used for a lot of things, but our equations, even in the best of cases, are merely approximations of what we observe in the real world. That being said, AI tools currently do, and will continue to, work the best for solving problems that are fully bounded in computers. In the same vein, AIists do, and will continue to, struggle when put in contact with the real world. For example, self-driving cars based purely on math with cameras and/or other sensors as input has remained elusive and likely will continue to be so. While incomplete solutions will continue to be worked on and developed, and may even perform great in certain circumstances, the unbounded nature of the real world means there will always be situations where the computer will not know what to do, and unfortunately when it comes to cars, such indecision can and will lead to accidents. Some people say that it will be better than current humans, statistically, yet companies will likely find any number of fatal accidents untenable due to public outrage, and lawsuits will threaten to put them out of business. In that particular case there's an interesting gap in the discussion if perhaps we should instead be raising the bar for human drivers instead of trying to replace human drivers altogether. Plenty of humans who drive cars go their whole life without causing an accident. This isn't to condemn companies who have gone after trying to solve the problem of driving with brute force math, but merely to highlight the true danger that modern AI produces. Due to how they are developed, the chance that an program will become sentient and do anything truly of its own accord is zero. However, the more we connect these uppercase A artificial lowercase I intelligence systems to real-world devices and applications, they will have unintended consequences and have the ability to negatively affect our lives. We're also getting to the point where, because more and more industry experts are relying upon AI systems to assist them in their work, human experts in all fields are getting worse at math and less understanding of how things actually work. AI is a tool, and like all tools can be used for great things, but until AI is widely recognized for what it is, a method of brute forcing math for problems we were too lazy to solve ourselves, it will continue to be widely misused and put in applications where the stakes of failures will continue to get out of hand.